You do know Elvis is dead, right?
No, Elvis is not dead. He just went home.
So let's talk about some basic regression vocabulary that hopefully you learned in your intro course. But let's be honest, sometimes you don't remember. Some classes didn't cover it all that well. I even know of intro courses that skipped it entirely. There are some more videos that talk about it in detail. But let me go over some brief stuff that perhaps you already know. We have a numerical response, specifically in this case, the weight of a wife. And we're going to predict it with the weight of a husband. This is not where we want to test their averages. We don't want to see whether on average do husbands weigh as much as their wives do. That's something that's already been studied a lot. In this case, we just want to see as we increase or decrease the weight of the husband, does that change what we predict for the wife? So what we need on this is a regression line, or a line of best fit where it goes through the data in the best way. And we're going to define best as smallest residuals in the y direction. We'll talk more about that in a future video. So our equation is going to be y equals beta naught plus beta 1x. In math class, they probably told you y equals mx plus b. We want to use this notation because in the future, we can add more slopes and do multi-dimensional models, which sounds a little more scary than it really is. But for right now, we're just working with a simple linear example. For example, if you tell me the weight of the husband is some value x, I plug it in here, times by 0.9, add the 50, and I can predict what I think the weight of his wife should be. Now, notice this 50 here is the y-intercept. That would be the value if you had a husband that weighed 0, which doesn't actually make sense. So this is not going to be of interest. But this is what we really want to test. In the next video, we'll talk more about that. I told you that the error was in the y direction. That's because if we know the weight of the husband, we want to know how much would we be able to predict the weight of the wife. And here we have a wife that is a little lighter than what we would have predicted, or over here, a little heavier than what we would have predicted. And I realize that all of you are thinking that you know a couple like here and a couple over there. That's rude. Don't go there. We are talking about some nice linear simple regression. One definition that we really need to talk about is R squared. R squared is defined as the percent of variability in y that is explained by the model, which doesn't make a whole lot of sense unless I show you with the picture. Notice we have wives that are that light all the way up to wives that are heavier, so there is a large amount of variability in total. But when we look at the regression model, the variability is smaller. How much smaller? How much of the total variability did we lose thanks to this regression? And I would say, just eyeballing it, it's about a third as much, which means we lost maybe 60%. So 60% of our variability in the weight of the wife can be explained with the weight of the husband. Some things to be careful of. You cannot use R squared in terms of how much variability there is in the data. It's specifically variability in what we're trying to predict. And don't say it's the percentage of the predictions that are correct. None of our predictions are ever perfectly correct. This is simply a measure of how accurate our predictions tend to be, but don't say that 60% of our predictions are correct, or that it's the percentage of the data that can be predicted. These are common things people put in their final project, and that's not the right way to talk about R squared. I'll knock you off if you do it. Keep in mind, we're talking about correlation, not causation. Common example, ice cream sales tend to go up at the same time that murders go up. Does that mean ice cream makes people want to commit murder? No, it's because ice cream sales go up in the summer. It also happens murders go up in the summer for reasons related to the weather. And so yes, there's a correlation, not causation. We're going to talk later about other reasons why R squared is not something you want to rely on to help you make models. Statisticians frequently are not that fond of R squared, but other people want it. So we need to talk about it and the proper way to use it. So here's basic regression vocabulary. Notice that the scales don't need to be the same. Ice cream sales are in dollar, murders are in numbers. That's okay. We just want to see as we increase X, does it change Y? And the next video will actually show how you can do a test for that.